Data structures are just different ways for you to store information in your computer's memory. Hi, my name is Adi. I'm a software engineer at Amazon. And in this video, I'm going to explain how data structures work in a way I wish it was explained to me. Arrays are basically continuous blocks of memory. So in a warehouse of memory, imagine you're saying, I want to rent units 100 through 150, a length of 50. It makes searching really easy. If you want to find unit 125, the 25th element, your computer knows it's just 25 from the start. From 100, it's a unit 125. But if you want to add something to unit 125, you have to move all your elements, all your pieces of data, all your items stored in 125 to 150, originally one space down. Additionally, it's a continuous block of memory. So if you want to go to having 100 elements, 100 pieces of items instead of 50, you can't have like them split apart. You need 100 blocks back to back. So the warehouse coordinator has to find like, where is a space in this warehouse that's 100 spaces empty in a row. Now, linked lists try to solve this. Basically, linked lists are, you'll store information in whichever location is free, and then you'll also put a sticky note, a pointer that points to where the next piece of data will be stored. So unit 150 might have data piece 1 and a pointer, a note saying the next piece of data is in unit 851, and so forth and so on. It's really good for inserting and deleting elements, but not that great for search, because if you want to find the 50th piece of data, you have to walk down 49 different units. Now you have queue, which basically stores like what came in first and gives that the first priority access. So if a bunch of programs are trying to access the printer, the first program that asks gets to go. Next, you have stacks, which say the last program or the last function that was called is the one that gets executed. So that basically means that as you're like programming and it's going down, it does the program that's most like recent or the lowest line first. This is how the undo functionality works. Next, you have graphs, which are basically these interconnections. So each node or each piece of element or each unit has its own like piece of data, and then it also shows everything it's potentially connected to. Next, you have trees, which split your data up in like halves, like unit 501 to 1000 goes in warehouse 2, and unit 100 to 500 goes in warehouse 1, and so forth. When you have a lot of data, like millions of pieces of data, it makes search really fast because you can get to any number within like 20 searches. And lastly, you have hash functions that use, or hash tables that use a hash function to make it so that you can find anything in constant time super quickly using a mathematical operation by putting a key. Like you say Apple and you get unit 187, but you can't store anything in order essentially. And so different data structures play different roles. They can make your program a lot faster or a lot slower based on, and they can like waste space in your memory versus not. And it really matters when you're working with a lot of information. And wasting space is space complexity, and wasting time is time complexity. And that's it. That's all there is to a data structure.